All June and July, we're talking to scientists throughout Texas and the Southwest to give us a glimpse at their day-to-day lives. Today, we're sitting down with Dr. Erika Hamden, a professor of astrophysics at the University of Arizona and an astronomer at the Steward Observatory. Dr. Hamden is one of the few lucky people on Earth who get to actually build telescopes. Thank you so much, Dr. Hamden, for joining us today. I'd love to start by asking about how you got into science. Do you remember when you first decided you wanted to become a scientist?
Well, thank you for having me. I'm really happy to be here. Actually, I remember the exact moment that I got interested in space because it's like the seminal moment of my life. I was like in first or second grade, and I remember I was sitting in our TV room and my mom came over one afternoon and she was like, oh, I just saw in the news that there's a contest. Scientists want to come up with a new name for the Big Bang, so you should come up with a name and submit it. And I was like 7, so I looked at her and I was like, what's the Big Bang? And she was in the middle of making dinner and she was like, well, I don't have time to answer, so go look it up. So I went upstairs to our encyclopedia. We were a really privileged family, so back in the 80s, we had an encyclopedia. And I looked up the Big Bang in the encyclopedia and I started reading about space and the beginning of the universe. And I was like, oh my God, this is amazing. And then the encyclopedia, the very last volume was actually an atlas. It had like maps of the United States and the world. And then it also had, in the last couple of pages, was a map of the solar system, and then a map of the galaxy, and then a map of the known universe. And I remember looking at that picture of the known universe and thinking like I could like feel my brain exploding. It was just like the coolest thing ever. And from that moment on, I knew that I wanted to study space. I wanted to either go to space as an astronaut or be an astronomer and spend my whole life thinking about it. And that's basically what I've done.
This is going to be an off the wall. Do you remember did you enter the contest? Did you rename the Big
Bang? I didn't enter the contest at all. And the funny thing is I think about that and that story and like, it's 2020 and we still call it the Big Bang. So like clearly nobody came up with a better name.
The contest didn't work. So in general, it seems like, at least in terms of your mom, did you find that people were in general support of you pursuing a track in science?
Oh yeah, so my mom was a high school biology teacher. I'm one of 5 sisters. So after she started having us, then she was a stay-at-home mom, but she was always really into science. And even when we were growing up, she would come to our classrooms and do these like science experiments when we were in elementary school. So she was really science oriented. She had a microscope and sometimes we would like look at stuff with the microscope. And my dad is actually a physics professor. So both of my parents are scientists and science was just like the way that life happened.
Did you receive any pushback at all? Were there any people that kind of looked at your career and thought that science wasn't suited for you? It sounds like your parents
were fantastic. I'm very grateful to them. So it's interesting because I never really experienced that. And I think I thought about why, because I know that for most women and especially for women of color that like they are told that they don't belong. And when I think back on my, like, especially my public school education, I grew up in New Jersey and went to public school for K through 12. And no one ever said that to me. And I think it's because I had so many sisters and my sisters, I'm the second to last. So all of the teachers that I had, they would have had my older sisters already and they knew like, oh, a Hamden, like this person is smart. We were all good kids and we're all very smart. So I never had to fight against someone saying, oh, maybe you're not good enough. And I can actually only think of one instance of it. And that was in high school when I tried to take a computer programming class. And none of my sisters had taken computer programming. And so that teacher didn't know who we were. And he asked me like, oh, well, have you ever done any computer programming? And I was like, no, that's why I'm taking this class. And he was like, oh, I think this might be too hard for you. He said all this stuff. And I was like a very naive, I was in like 10th grade. So I was like, oh, well, a teacher doesn't think I could do it. And I've never heard that. So I guess I'll believe that. So I dropped the class and I ended up taking a drafting class, which in terms of like what I do it was incredibly valuable because I do a lot of mechanical design and hardware building. And so like actually the drafting class turned out really well. But that was like the one instance. And now when I think back on it, I'm so annoyed at that teacher. Like I would have been great at it. But a lot of times I think I benefited from, having that really strong family support. And from being like, once I was in the class, it's very obvious that I was really good at math and science. So, um, nobody was really discouraging about it. And I just had this really strong belief in myself also. Like when that teacher told me that I maybe shouldn't do computer science, I didn't think like, oh, maybe I'm not good enough for anything. I was just like, oh, this is one specific instance and I'm not going to generalize this in any way. I always felt like on my own, like, oh, well, I can do anything. And so I feel like that has helped too, because maybe there were people who were discouraging, but I just totally blocked them out. Their opinions are bad, so I don't need to listen.
Well, I think that's definitely a great way to think about it. So now you work with telescopes. Did you begin your career fascinated by telescopes, or did something in your academic career push you in that direction that you wouldn't have normally considered?
So I didn't realize that you could be the person who builds telescopes until the end of my college experience, until my senior year. And I started working with a research scientist who built instruments. He didn't build the telescope, but he built like the camera system and the spectrograph. And I slowly came around to the idea of like, oh, this is just a job. Like this person isn't necessarily the person who's like going to the telescope at night and taking the data, although he also does that. And he's not necessarily the person who was doing simulations or like theoretical work. But actually, in order to do those things, like you need the telescope. The telescope is very important. And it just kind of clicked with me because I have always enjoyed like hands-on things in my, all of the lab stuff that I'd ever had to do in school, like electronics lab or chemistry lab. Like I was really good at the tactile things. If you like need to put something together, you need to like create something. And the only other job that I have had was that I was a chef for a year. And like, that's the same thing where we're like putting something together and like building a thing. And I just really find that satisfying to design something creative and then have it work. And so then I realized when I went to grad school that like building the thing was actually the combination of the stuff that I really like. It's still astronomy, you're still thinking about space and doing observations, but then you get to have this tactile hands-on experience. And a lot of astronomy, you're observing stuff that is so far away that there's no chance that I'm going to ever be able to go to another galaxy or see even another star up close. But I can touch the telescope, and that's really satisfying.
Yeah, I think for most of us, at least, that aren't dealing with this, you think so much about the images that come back from that, but you hardly think about what goes into creating a telescope.
Yeah.
So would you be able to explain to someone who's unfamiliar in the field, how many people does it take to build a telescope? What different fields are involved? I mean, it seems like it would be a very people and labor intensive job.
Yeah, it is a lot. So the number of people kind of depends on like the scale of the telescope. So if you look at something like the Hubble Space Telescope, that was like thousands of people worked on it. And the conception for the idea and in the 40s, and then people were working on it for like 40 something years until it got launched, so that people have been working on it for 30 years since it's been launched. So probably, people who like physically designed something, manipulated something, put something together, did the software, I would say like close to 10,000 people have probably worked on Hubble. For a telescope like the telescope that I built, Fireball, that's a much smaller project, but it's still like 30 people are involved in the team. And out of those people, there's not just astronomers, there's like mechanical engineers, electrical engineers, there's general like technical people, there's the all the optical people who are like, they're technically not astronomers, they're optical engineers, so they do like designing the optical systems and checking the mirror surfaces. And so there's just this huge range of skills. And the fun thing about my job is that when you're the person who is like leading the team, you get to learn all of those things. So like, I'm not a mechanical engineer, all of my degrees are in astronomy, but I've learned some mechanical engineering so that I can design parts or review someone else's designs and make sure that they're going to do what we need to do. So it's been it's been an incredible learning experience, which is actually, I think, what I enjoy the most, is just like learning new things and trying something new.
So you mentioned Fireball, which is by far the coolest name I've heard for a graduate project. Could you briefly describe what the goal of the Fireball project is?
Yeah, so Fireball is looking for hydrogen, which is the simplest, most common element in the universe. It's just a proton and electron. We're looking for hydrogen around galaxies, and we're looking at really distant galaxies because we're trying to figure out what makes them different from galaxies today. And we think that these distant galaxies have huge clouds of hydrogen, and like by huge, I mean that they are like several times bigger than the galaxy itself, but it's really diffuse because it's out in space. It's just like a big old cloud of hydrogen that is slowly, possibly flowing into the galaxy. And that hydrogen, once it gets in the galaxy, it'll make new stars and it'll keep the galaxy kind of vibrant and growing. But that hydrogen is really hard to observe because we're not looking at stars, we're not looking at the galaxy, we're looking at a cloud of hydrogen atoms. And so you have to have a really good telescope that's really precise and has a lot of sensitivity, because the hydrogen atom itself emits a photon like every so often. So we're trying to catch like a handful of photons from a telescope that is hanging from a balloon in the stratosphere. So it's hard, but it's a really exciting science objective, because we know that in order to go from those distant galaxies to galaxies that we see today, there have to be some changes in the environment of the galaxy. And so we have to observe this hydrogen to actually see like how much is there, how is it moving, is it there at all actually, or is our theory somehow wrong?
And so what is coming up in September of 2020? First of all, is that still coming up in September of 2020?
So we were actually doing the alignment of the spectrograph and the instrument we started in February, and I had some of my students and postdocs were out in New York City, which is where we were partnered with Columbia University. So they were working on the alignment and it was going really well. And, we go out there for trips and then we come back, and they came back in like mid-March, and we needed to go back like a few more times to just do the final stuff, and then everything fell apart. So we decided to move the launch back to September of 2021, just because we're not going to, the science is important, but the people that do it are more important. So we want to make sure that everyone's safe, and we're right now working out ways where the people that are on the ground at Columbia already can maybe video chat with us, and we can talk them through the alignment and we can do it together. And then it's going to slow things down, but it'll be safer. And the balloon launches happen basically once a year. So the wind is only good in September. And since we knew that there was no way we were going to do this September, then we have to wait a full year until next September. But part of doing telescopes and building telescopes is that like things never go the way that you think they're going to go. So like this is just one of many challenges.
Yeah, so if you're watching this right now, be sure to check back in with Dr. Hamden in September 2021 and see kind of how that's going. Do you remember having any major aha moments in your career? Do you have one that stands out to you?
Let me think about that. I've had a few times where I have been like struggling with a problem, and just like something in the experimental setup seems weird, but I can't really put my finger on it. And then I'll go away, and like the answer will like pop into my brain. Like I've realized a lot about my, the way that my brain works, that I need to like remove myself from the situation and then let it like be working in the background while I like do something else, or like take a shower, or like do yoga, and then it'll like something will turn on. So that happens like kind of frequently if you give yourself the like space. And it kind of depends. Like there was one where I was testing the detector that we use for Fireball that I spent a lot of time working on, and we were trying to test the noise. There's no light on the sensor, so just kind of like the background level of noise. And the noise level seemed really high, and it wouldn't, we would change conditions in the detector and it wouldn't change the noise level. And I was like, this is so weird. This isn't what's supposed to be happening. And I had a friend over, during this time, and we were fixing a leak in the shower of my apartment. And he was like, oh, so tell me about that problem you're having at work. Cause he worked in a similar field. And I was talking him through it. And then in the middle of that conversation, I was like, oh, I know what's wrong. Never mind. I know what's wrong. So it just like, I found that in order to have those aha moments, you have to actually give your brain the space to be like doing something else, and then it'll like swing back around.
You're answering the problem without even really
turning. It's like putting some extra cycles in the background on it.
Have you encountered any major setbacks in your career? And if so, how have you overcome those?
I've actually encountered a lot of setbacks. There's a few that like immediately spring to mind. The biggest one was actually when I first went to college. I went to MIT and I dropped out after a couple of months. It's like I didn't even finish the first semester. I dropped out after Thanksgiving. And I was in a really bad state of mind when that happened. And I had to, I was really unhappy at MIT and I didn't feel like I could stay there. I didn't feel like I was going to have a life that I'm happy with if I stayed. And when I left, I felt like a huge failure. Like I had so much of my sense of worth was related to my academic achievements. And then I had dropped out of college. I was a college dropout and I just felt like such a huge failure. And I really had to like rebuild myself after that and realize that like, no, I'm valuable just because I exist. And my value as a scientist is great, but it doesn't have anything to do with my value as a person like every day. And I reapplied to college and I spent that spring working at a Borders in the cafe at the bookstore and taking classes at the university where my dad teaches at Montclair State. And I just kind of made it through and figured out like, what did I want and what was important to me and how could I make sure that every day I really liked what I was doing. And then when I went back to college and all of my choices after that about going to grad school, about where to go for a postdoctoral position, I've tried to hold on to that of like, well, what's going to make me happy and what is satisfying and valuable, and not like, what does everyone else think that I should be doing? And so that was a tough thing to go through, especially I was like 18 and I like don't know anything about the world, but I feel like it was a really valuable experience and it's been really helpful in me making good choices later on. And then with Fireball, there have been so many setbacks. Like I feel like the whole story of Fireball is a setback and then overcoming the setback and then a setback and then overcoming the setback. When we first went out into the field in 2017 to try and launch the telescope, that year there was a terrible hurricane season and the Gulf of Mexico kept getting hurricanes. And so in New Mexico, where we do the launches, it rained for 6 weeks, almost every day. And you can't launch a telescope in the rain. So we had spent 10 weeks in the field waiting, and then the weather was bad. And then the stratospheric winds that we rely on, like they changed direction. And so we couldn't go. And that was incredibly disappointing because I had thought about all these things that could go wrong with the instrument itself. And I hadn't thought about like the weather not cooperating. It like never occurred to me that was one of the possible outcomes. And then the next year in 2018, we went back to launch it. And, in this case, the weather cooperated and we actually got a launch. And it was really like, it was one of the best days of my life when the telescope finally launched. And then it got up to the stratosphere and the balloon had a hole in it. And so we didn't actually get the data from that launch, even though all of our stuff worked well and correctly. But and then it crashed, and then I had to think about like, well, why am I doing this? Like, this went from being the best day to like one of the worst days of my life. And I think that those events kind of validate my view that you have to be happy in the work every day, because if you say to yourself, oh, well, one day when this is done and when it's working, then that's going to be the satisfaction and I'm going to be happy with the results. But like, you don't know that day is ever going to come, or that the results are going to be good, or anything. So you have to, I feel like it's really important to just be in the moment and in the day and feel like, oh, this is great.
And lastly, do you have any advice for young people who are interested in pursuing a career in astrophysics, or just a STEM field in general?
Yeah, my number one advice is that you belong, and don't let anybody tell you otherwise. A lot of people who are in astrophysics especially, but in science in general, like society has this view of scientists as like these lone geniuses. And I think a lot of people look at that stereotype and they say like, well, I'm not a genius. And like, you don't have to be a genius to do science. You just have to be tenacious, and you just have to keep going. And you have to be, careful and keep track of your data and stuff, but it doesn't, there's nothing about it that requires someone to be a genius, or somehow like this totally unattainable ideal. And I think that's really important to remember, that most science, nearly all science, is just done by regular people who are like, oh, that's weird, and they want to know more. And that curiosity and the willingness to like be wrong and mess up and try things out, like that's all that it takes to be a good scientist.
Well, thank you so much. If anyone wants to keep up with you or the work you're doing, is there a place they can follow you?
Yeah, so I have a Twitter account that is just my name, Erika Hamden. And I have an Instagram account also, which is the same thing, Erika Hamden. And I post about random stuff, and when we're out in the field, I will sometimes write about that. But that's probably the best way, is on social media.
Okay. All right, well, thank you so much. I really appreciate it. Make sure to follow Dr. Hamden, and thanks again so much.
Thank you for having me.